A very good morning. Welcome back to our lecture series video on measurements and instrumentation. We are on the process of discussing the first unit of the subject measurement and instrumentation. This is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, SNS College of Technology, Coimbatore. We are dealing with the first unit, the fundamentals of measurement system. The last topic what we discussed is about the functional elements. Today, we are going to discuss about the static characteristics of the measurement system. Come, let's have a small recap about the previous topic. The last topic what we discussed is the basic functional or the generalized elements of the measuring system. They are classified into primary sensing element, variable conversion element, variable manipulation element, and the terminating stage. We have all discussed about the various classification of these elements in the previous course. The primary sensing element is the first sensor which senses the data, which gives the signal to the conversion element, then the variable manipulation element, and the terminating stage. Let's empathize the need for a static characteristics. The static characteristics are required to evaluate the accurate and reliability of the system. Studying the static characteristics helps in understanding how accurately and consistently an instrument measures a steady input. The static characteristics is also responsible to calibrate the instrument's property. Knowledge of static characteristics such as linearity, sensitivity, and resolution helps in choosing the right instrument and performing correct calibration for a given application. What are the different static characteristics that the system possesses? The different static characteristics are listed over here, like accuracy, sensitivity, reproducibility, resolution, drift, tolerance, precision, linearity, repeatability, threshold, stability, and range. So these are considered to be as the various static characteristics of the system. The static characteristics are the criteria for instruments measuring slowly varying or the constant quantities over a time period. Accuracy. Accuracy is the degree of closeness to the true value. It is measured with the formula m minus t divided by t into 100. Precision. It is the consistency of a repeated measurement. This could be explained with the four scenarios. So we all understand the concepts of bull and eye through an archer. What is accuracy? Accuracy is the true to intention. How accurate the value is to the center point. What is precision? The precision is the one what we use from the first value. How close the values are to your first value. You could differentiate accuracy and precision from these four diagrams. Sensitivity. The smallest change in the input that instrument response is called as the sensitivity. How sensitive the element is for your system. Linearity. Deviation from the ideal straight line behavior is the linearity. You could see the various linear behavior of the system in the calibration curve. Resolution. Minimum detectable input increment causing the output change. What is threshold? Threshold is the minimum input producing detectable output. Range or span is the minimum to maximum measurable value from the given value. The resolution is the one which gives a good concepts of understanding. Stability. Stability is the ability for the system to perform through operating the life. There are various types of drifts, that is zero drift, span bar sensitivity drift, and the zonal drift. Zero drift is a gradual shift in the calibration baseline. Span or sensitivity drift is proportional change along the measurable scale. Zonal drift affects specific position or portion of the measurement span. We could see on the right side the various drift behavior over the different time period. Reproducibility. Reproducibility is the degree of closeness of the repeated measurement over a time period. Repeatability is the variation in scaled reading, random in errors. Error classification are different types, one is systematic errors and the random errors. What is the various application? The thin film fabrication in electronic materials. Film thickness requires nanometer scale accuracy. Small mass variation also can give us a different problem. Experiment data comparison over here, where the microbalance demonstration significantly better precision for the lower variable. The various system standard comparisons are also given here. Let's summarize the topic what we have discussed in today's class. The M&I deals with the concepts of various instrument characteristics. They are classified into static characteristics and dynamic characteristics. Static characteristics are listed like here: accuracy, precision, linearity, relativity, sensitivity, hysteresis, dead zone, threshold, and loading effects. So these are the references and key takeaways from the video. Thank you for joining. Let's meet in the next session for discussing the next topic for the course, Measurements and Instrumentation.